All right, so tension and connected objects continued. So the last set of questions, it was just a rope attached to a single object with someone or something putting a force on the rope. But now what we're going to do is we're going to connect that rope to another object. It might be that that rope will go up over a pulley and connect to another object down here. Okay? And so there would be tension pulling up on this guy, M1, and also tension pulling up on this guy, M2. And this we could call T2 and T1. Okay, remember what we said about the pulley. We said a pulley really just changes the direction of the force. So if T1 is pulling one way, it should be equal and opposite to T2, okay? Because all the pulleys do is changing its direction. Oftentimes, when we have pulleys involved, we will draw our objects in a straight line. What are the forces acting here? Well, there's Fg1 acting down on this side, the weight of M1. So it would be pulling out like this if it was in a straight line. And the weight of M2 would be acting down on this side. So it would be pulling this way. So it's kind of like they're in a tug of war. And which one wins? Well, the heavier one does. And what are the tensions doing? They're in here in the middle. M2 is pulling on M1 and M1 is pulling on M2. And really, what are they going to do? They're going to be equal and opposite. Newton's third law tells us if one object pulls on another object, the other object must pull back with an equal and opposite force. So before we get into the actual objects, we need to talk for a minute about two types of forces. One type are called internal forces. And this is when we're looking at a system. And for those of you who have taken or are in chemistry, I'm sure you've talked about a system. So for us, a system is like the group of objects that's connected together, and we're not looking at anything from the outside. So M1 and M2 and the rope, and the pulley, they're all in this system. And what are the internal forces? They're the forces that are acting between the objects in the system. Okay, so tension is an example of internal forces. So they are the forces that are acting between the objects in the system. But look what's happening here with the tension. Really, they're canceling each other out. So internal forces do not affect the motion of the system, right? It doesn't matter how big T1, FT1, and FT2 are. They won't change the acceleration of the system. What determines the acceleration of the system? Fg1 and Fg2, and they are called external forces. So external forces are forces that are acting on the system from the outside, like gravity, right? Gravity's pulling from the outside, pulling both of these down. Friction is often seen as an external force. So some of the other questions we'll be doing here, you'll have a box on a table, and it'll be connected to another one hanging down, right? And so as this one gets drug across the table, unless the table is frictionless, then there'll be a frictional force acting back. So what are external forces? Gravity and friction are the two most common examples of external forces. Now, to figure out which way the system is accelerating, you need to look at then the external forces, because they're the ones that determine it. So if we were to draw this second picture in a straight line, right, Fg, if this is 2 and this is 1, then Fg2 would be pulling this way, and friction would be pulling back. And friction on number 1. There's no friction on number 2, it's hanging straight down. And so you would have to see which one of these is bigger to make it accelerate. Hopefully you would realize Fg2 should be bigger because friction's never going to make it pull in the other direction. Okay? And if you want to find the tension, then you need to look at like one of the objects. Right, the sum of the forces on one object, because then the tension wouldn't cancel out. But I'll get to that in the next video. Just one last thing in this one, and then I'm going to cheat, and the next video is one I made in the fall. And that's assigning direction. No longer can we say up is positive if it's something that looks like this, because one will be moving up when the other will be moving down. It always, 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 always has to be the direction of motion is positive. So if M2 would be bigger than down, M2 moving down would be positive, and M1 moving up would be positive. And that would be if M2 is greater than M1. The opposite would be true if M1 was greater. Okay, so you gotta use the direction of motion as positive. Okay, and I do think if you think of them lying in a straight line, it'll make your life easier. Okay, so this is just a short little video to connect the tension we just did to the Atwood machines that are coming. And so please watch the next one that explains Atwood machines. Thanks.